Fractions, why are they so hard? It's really just two numbers separated by a line, but for some reason, as humans, we find it difficult to work with or to think about fractions when they're written this way. It's much easier for us to think about decimals or to understand what a decimal is because we think in terms of tens. If a decimal has a tenths place, a hundredths place, a thousandths place, it's easier for me as a human being to think about numbers in base 10. I have 10 fingers. I can count to 10 easily. I have 10 toes. But for fractions, it's just kind of a different system. So what we often miss is we just miss the way that these relate to each other. If I look at 1/2 as a fraction, I should be able to recognize that 1/2 is the same as 0.5. This is the decimal, this is the fraction, but these are still, they're referring to the same quantity, the same number. Or I could say 50% as a percentage. These are all referring to the same amount, and we oftentimes miss that when we're dealing with fractions. So why even use fractions? It seems like we're just kind of adding an extra difficult layer to math when it's already hard enough. And the reason for that is because we can rewrite repeating decimals as a rational number. And when I say repeating decimal, it's a decimal that goes on and on forever with no end. And it would be very tedious for us to write out kind of that long number. But it's easier for us to write a rational number. When I say rational number, I just mean this is a number divided by another number. This is a ratio or a fraction. So if I just simply take my calculator and I divide 49 divided by 333, this is going to give me a long decimal. It's going to give me 0.147, 147, on and on forever and ever, 0.147. Or I could rewrite this as 0.147 repeating, but I'm still kind of losing some information here. We really, here we go. If we write that as the fraction, 49 over 333, then I can understand that this is the ratio between these two numbers, even though it represents the same quantity as these. On the second one here, I have 16 divided by 99. If I do that on my calculator, again, I'm going to get a repeating decimal, 0.161616 on forever and ever. Or your calculator might round that to 2 at the end because our next number is a 6. It might do it either way, but it really is 0.16 repeating, right? So I can write that. Let me erase that too. It's going to bother me. So I can rewrite that as 0.16 with the line on top. And again, that just means 0.16 repeating forever. It's because this ratio does not work out to a nice decimal. It doesn't round to an easy, perfect decimal. That number would continue on and on forever. And our last one is 1 divided by 6, or 1/6. Again, if I just type this into my calculator, this is going to give me 0.1666, so on forever, repeating decimal. So almost kind of like the one here in blue. But this one I would write not as 0.16 with the line on top. This one would just have the line on top of the 6 like this. All right. So that is a repeating decimal. These are rational numbers. So let's talk about these. Here I have some more examples of fractions, some different values here. And this just says organize these basically from least to greatest is what this is telling us to do. For my human brain, this is pretty much impossible to do just by looking at it. I can't really tell, what is 10/3, what is radical 19. It's very hard for me to organize these into actual values and actual numbers that mean something to me. You never go to the store and you see, hey, these clothes are for sale. They're radical 19 off of the ticket of the sticker price. You don't really see these numbers too much in real life. So it makes it easier for our brains if we convert these into decimals. So right, if I do 10 divided by 3 on my calculator, this would give me 3.33 repeating. If I type in the square root of 19, again, if I just type that into my calculator, This will give me about 4.35. This one's already decimal, 3.8, that's already a decimal. So I can just leave that as it is. For the fraction, here I have a mixed number. This is -2 and 1/3. So I know that 1/3 is 0.3333 repeating. So I could really just write that as -2, and then just using that 1/3 would be 0.33 repeating. So now just having these in a decimal form makes it kind of easier to work with. I know that the negative would be the smallest number because it's less than 0. The next biggest number would be 3.33, so 10/3 would go next. The next biggest number from that is 3.8. I could put that next. And then 4.35, that would be the largest number here, the biggest value. So radical 19, I put that right there. All right, so again, these numbers, it's hard for us to deal with these when they look like this, when they look like a rational number, like a fraction, or like a radical, a square root. So just by changing these in decimal, it's easier to just kind of recognize what we're dealing with here. So one other thing I want to talk about in this video before I finish up, let's talk about multiplying and dividing fractions. So when I multiply, this is really the easiest operation when I deal with fractions. Multiplying, you're just multiplying straight across. Okay, 11 times 4 gives you 44. 3 times 5 gives you 15. And then just notice here we had a negative times a positive. Negative multiplied by a positive gives you a negative. All right, and that's really all we could do with this. For us in these kind of higher level math classes, in these algebra, MCR classes, what we would do with these is just leave it as an improper fraction. When you're younger, when you're in grade school, you would change that to a mixed number, or if the question asked you, you could change that to a mixed number. But pretty much as we get into higher math, we're just going to leave it as that improper fraction. All right, let's try a harder one. So here I have a fraction times a mixed number. So the first thing I want to do here is just kind of rewrite this as an improper fraction. So I'm just going to bring down that -7/12. For this, here we go. This is -4 2/5. The easiest way to do this is watch. 4 times 5 is 20, plus 2 is 22. All right, so just one more time, what I did was 4 times 5 is 20, plus 2 is 22. So I can rewrite that as an improper fraction, -22/5. And now I can multiply these together. So 7 times 22, or really -7 times -22 is positive 154. So those negatives cancel out. Negative times a negative gives me a positive. And then on the bottom, 12 times 5 is 60. And again, we would leave it like this. This is an improper fraction. The only thing I would say here is I can simplify this still. I could reduce this fraction. I noticed that the top is even, the bottom is even. So I could divide 2. 60 divided by 2 is 30. And 154 divided by 2 is 77. So I could reduce a 2 out of that fraction, and that's really the only thing I could do here. Nothing else would divide out from 77 and 30. So let's talk about one last thing, dividing fractions. It's really kind of the same thing as multiplying. When I multiply, I just did the tops, the top times the top, and the bottom times the bottom. When I'm dividing, I'm really just multiplying by the reciprocal. Or you might have heard it before as keep, change, flip. Keep, change, flip, KCF. But it's really just multiplying by the reciprocal. So let's start by first just changing this into an improper fraction. 1 times 3 is 3, plus 2 is 5, and it was negative. And then this was 4/5. So what I'm going to do here is I'm keeping this the same. I'm going to change the sign from divide to times, and then I'm going to flip the last fraction to 5/4. So this is called multiplying by the reciprocal, or you've probably heard it before as keep, change, flip. These both mean the same thing though. So now we can just multiply these straight across. 5 times 5 is 25. It was negative times a positive, gives me a negative. And then on the bottom, 3 times 4 was 12. All right, and just like last time, there's nothing else that I could simplify or reduce out of this. There's no number that I can divide from 25 and 12. So this is my answer. I can't reduce that. I can't simplify it. That would be my final answer. So that's kind of the basics. That's the basics of fractions, what we get wrong about fractions, why we're bad at them, and just the basics of multiplying and dividing.